Hello, everyone. To start with, I just want to say that myself and the presenters tonight are meeting on the traditional lands of the Kaurna people, and we pay respects to their elders, past and present. So, Nin Hamani, everyone, which in Ghana means hello, how are you? So for those of you who don't know me, my name is Charlotte and I'm from the Port Environment Centre. And for those tuning in from outside of South Australia or who haven't heard of us before, we are a community-driven organisation and a gathering place that supports people to live sustainably and to value and care for our environment. So we have a particular focus on the coast and marine world. So we host a range of kind of events and activities. Most recently, we held a series of verge tours about how to kind of set up your own verge garden and what this can do for cooling the climate. Next month is Plastic-Free July. So we thought it would be a great opportunity to get some of the researchers who are studying plastics and what this is doing in the environment and see, what the current research is and how we can join in and get involved. So we've organised some great speakers for tonight. First off, we have Michelle Blewitt from Osmap, which is the Australian Microplastics Assessment Project. And a special thank you to Michelle. She's currently on day 3 of COVID, so might struggle through it a bit, but we're very grateful that she could join us today. And then we have Nina Wootton from the University of Adelaide, who studies microplastics and their presence in seafood. And then finally, we'll have a quick word from Chris from Adopt a Spot, all about what their volunteer community does and how you can get involved. So if you have any questions, feel free to save them till the end and we'll try and get to them at the end, or you can just pop them in the chat as we go. And also just a friendly reminder to keep your mics on mute. And yeah, we'll hand over to the speakers now. So first up is Michelle.
Hi, everybody. Thank you. I'm just going to share my screen. Thanks, Charlotte, and thanks, Emma, for inviting me to speak today. Probably not the most ideal to be doing day 3 of COVID, so forgive me for my croaky voice, but I'd also like to pay my respects to the Aboriginal people joining us today on the lands in which we meet, the Kaurna people of the Adelaide Plans, and the waterways in particular that we're going to be talking about mostly tonight. Tonight I'm just going to talk to you about our program, Osmap, which is the Australian Microplastic Assessment Project. Some of you may be aware of it, some of you may not, which is great, even better. So a little bit of background briefly. My name is Michelle, as was kindly introduced. Thank you, Charlotte. I am the Program Director of AUSMAP. The program's actually based out of the Total Environment Centre in Sydney, but it's a national citizen science program, which I'll explain to you as the talk goes on. But it's a nationwide program, but I'm based here in Adelaide. And I work very closely with the lovely people at the Port Environment Centre. So I'm just going to talk to you about the program and how you can be involved as part of this national citizen science project. So plastic, I'm just going to give you a bit of a rundown. I know you're all aware of it. It's Plastic-Free July in a couple of days, thank goodness. But we realistically should be living fairly much a plastic-free life wherever we can. These are some images that we really don't want to see in our livelihoods, but they're images that we see all too many times. Actually, my brother, just interestingly, he went and got groceries for me yesterday and he came home with some bananas in a plastic bag, and I went, oh my God, have I not taught you anything? Seriously. And I almost, he's like, oh God, I forgot. I'm like, seriously. But I mean, you can see the images here. These bananas, for example, are already peeled for our beautiful pleasure and wrapped in plastic, wrapped in a polystyrene. Lemons likewise. But these are consumer choices. If we choose to keep purchasing these things, then they're still going to do it. So it's about us as a community to say, no, we don't need these things packaged in plastic. So we go that first step to reduce our own plastic footprint in our everyday lives. Unfortunately, plastic as it is today is on an upward trajectory. We're around this point here, but if we continue as business as usual, and I know there's been some recent results coming out to say that it is leveling out or declining in what's being found out there, but unfortunately not when it comes to microplastic, and that's what Nina and I are going to focus on a lot tonight as well. But if we continue on that path that we're continuing on now, it's going to virtually double in our environment in the next 25 years or so. But if we do a significant change to our own personal footprint, we can see a significant decline as time goes on. It'll never ever disappear. Unfortunately, every piece of plastic ever created in this universe is still here in one form or another. It just gets smaller and smaller. And that's what we're going to talk about today. Excuse me. So unfortunately, these are scenes that we see all too often. This is a scene in Cooks's River in Sydney, and you can easily say, oh, it's not here in our backyard. But in fact, I've got results for good old Adelaide that will shock you and surprise you in a little while. But all of this, most of the stuff that lands on our shorelines and in our waterways comes from us from land. The ocean is downhill from everywhere. And once out there in the environment and then breaks up into smaller and smaller pieces. So it really is an urban issue that we're looking at. And so we have to take a holistic and urban point of view on trying to get rid of this stuff as well. So as I said, once it's out there in the environment, it breaks up, not down. As I said, it never ever goes away. It just breaks up into smaller and smaller pieces along the way. There's different size categories. The stuff that we can see quite regularly, the bottles and the cups that get thrown around, not so many straws though these days, which is great, is what we call macro debris or macroplastic. We like to refer to that as macro debris, not just plastic, because it can involve anything that's human generated and human made. As it gets smaller and smaller, it fragments into pieces that become micro and then nano, and so it's airborne, pico, we're breathing it in. Studies that colleagues have been undertaking is that we breathe in about 12,500 pieces of plastics in our own homes every single year, just through everyday life. The stuff that we like to look at for Osmap, which is because we're doing citizen science, is what we call microplastic, which is the 1 to 5 millimeter size. So it's about half the size of your little pinky nail. And it's the stuff we can still see before it fragments into smaller and smaller pieces. So the sources are many. So many of you may have heard the term nurdle, not noodle, or as someone referred to it recently to me. Hopefully people are aware of some of these terms. Nurdles or resin pellets, once upon a time called Mermaid Tears, are the small round pellets, similar to that last picture. Actually, if I go back, I'm not going to try and go back because, there we go. She's holding one there in their fingers there. They're like round little fish eggs almost, and that's why they can be even more detrimental to our environment and to the biota that we have and us as well. But they're from the industry, so that's what plastic is made. That's what we call primary microplastic in its base form. So when plastic is made, it gets made into these small pellets, and then that gets molded and coloured into other forms and other plastics. We also have what we call microbeads. So microbeads, if you ever wash your face or clean your teeth with anything that's made of granules, that feels granular and feels good to clean your teeth. Often the Garnier face scrub, once upon a time, is made of plastic. And unfortunately, then when you clean your teeth with it, you ultimately swallow some of it, or then you spit it down the sink, and it just gets washed out straight into our environment. Secondary microplastics are things, here goes the voice trying, such as the fragmentation or the breakup of bottles and things like that are left out in the environment, and microfibers from our clothes as well. A couple of other significant things I should point out, which are becoming more and more apparent in the environment, is in this petri dish down here, and these little black dots is what we call rubber crumb, and the grass fragments here, the grass strands that you can see, are synthetic grass. So many of these synthetic grass fields these days have a base of rubber, which is all made of synthetic items. That now gets washed into our our waterways, and that's the next environmental nightmare that we're not going to cover today. That's the subject of next time's talk, perhaps. So all of these things then wash into our environment. Unfortunately, once out there as well, not only are these different types of plastics made up of different polymer types, so whether it's a water bottle or whether it's a milk container, a PVC pipe, and they all have different hazard ratings. It's a very arbitrary scale. Even right down to the nail varnish that we paint on our fingernails, they're actually made of plastic. And then once out there in the environment, the plastics then act like magnets or sponges that then soak up other environmental contaminants in our oceans, such as DDTs and phthalates and all of those nasties that are already in our environment. And then we get a double dose of whatever animal might be consuming potentially that plastic, they get a dose of that as well. So what are the environmental impacts? Well, the visual factors of plastic are very evident in the media. We often see footage of, suffocating turtles and birds and fish and all of the visual element of plastic interactions. Unfortunately, it's the stuff that you can't see, the small stuff that we're really concerned about. And I know Nina will talk about this much more detail than me. This is an Albatross Chick. These guys spend 90 days on land before they fledge and fly out to sea. Now, this one poor bird was filled with all of these pieces of plastic, over 350 pieces of plastic in that one chick's belly. It's not just small stuff. You've got toothbrushes, cigarette lighters, all of these different colours were in that one bird's tummy. And these little black dots down here on the bird's bottom are actually squid beaks. That's what this bird should be being fed. But their mums are out there, mums and dads are foraging, looking for anything that is potentially good for them to eat. Unfortunately, they're there feeding these poor birds. So not only did that bird die of no doubt starvation because they can't feed on anything else, but also perforated stomach, chemical poisoning, you name it. And that is the result of almost every single seabird on Earth, unfortunately, nowadays. So what is that potential risk to us? And as I said, Nina will talk about this. But obviously, once out there, the plastic gets a dose of extra chemicals. It's made of chemical compounds. It's then ingested by whatever is out there potentially in the environment, whether it's a mussel, an oyster, a prawn, a fish. Now, we don't eat the stomachs of fishes necessarily. However, all of that can seep into the flesh, which is what we like to consume. So there's potential exposure to us. And there's a lot more studies nowadays coming about the impacts of ingestion in seafood. And as I said, Nina will talk about this, but studies by colleagues of mine at University of Newcastle and Scott Wilson at Macquarie, who's our research director, has considered that we consume about a credit card size worth of microplastic every single week. Now that's amazing. And even, unfortunately, even if you're a vegetarian, it is now considered that it's being taken up by the roots of vegetables as well. So there's no getting away from it, unfortunately. So as a result of all of this, there is obviously the increased media, and we're all becoming very much more aware of these issues, both from the recycling aspect as well as the war on waste. And unfortunately, and you're all here because of just this reason. And that's why we started AUSMAP in the beginning. It's about a 4.5-year-old program now. So it's a national citizen science program that aims to map microplastic around Australian shorelines by using a scientific methodology, but using citizen science. So we engage non-professional people in using our scientific methodology so we can compare samples across our country. And I'd just like to add in there that we are also fortunate to win the prestigious Eureka Award from the Australian Museum last year for the innovation in citizen science. So someone out there thinks we're doing a good job. So I'm very proud of that. And that was a fun job. I know that Mel's online watching and she was here to join in that celebration. It was pretty fun. So what AUSMAP's all about is, hang on, sip of water, sorry. What AUSMAP's all about is mapping where these hot spots are. It's then about trying to figure out, okay, what is there? So we need to look at what the type is, how many are there, what the colour is. And then we can go back up catchment and figure out, okay, where's it coming from? And once we can figure out where it's coming from, how do we stop it? But none of this will work unless we have community engagement and behaviour change. And that's what it's all about. You're here tonight because you want to learn more about it. That's the first step in trying to minimise plastic in our environment. Right, so we go out there, do some field work. We only concentrate on shorelines. We look at the last significant high tide line. We're not interested in what's accumulated over time, unless we're in specific spots and like in wetlands. But generally speaking, it's the shorelines that we're looking at because we want to see what's coming in that last high tide. We look at the big stuff, the greater than 5 millimetre size, and the small stuff, the 1 to 5 millimetre size. We do look at a subset of the smaller stuff as well. So how is this data used? We've so far collected about 380 samples from across Australia. These dots signify our different lows ranging from 0 to 10 pieces per square metre up until the purple, which is greater than 10,000 pieces per square metre. We do this by training people across the country in different training days, and then we get people involved, whether you're a local community, whether you're a retired person, whether you're a school teacher. Our best actual people that help us are retirees, and it's fantastic. We've got well over 40,000 hours worth of volunteer work out there now. Most importantly though, we've removed well over 3.5 million pieces of microplastics from our shorelines, but there's obviously lots of gaps, and that's what we want to fill in the coming time. So here in South Australia, you know, we thought it was a little pristine here until, and that's what we were told when we started here. Our beaches here are pristine, fairly pristine. You know, the coastal beaches aren't too bad. You can see here lots of green spots, but then you can see some really big black and purple spots right over the front, over the top of Adelaide. If we zone in there, our sampling first started around West Lakes because I was advised of these areas by people from one of the schools up there that was looking at microplastic. And we had results there well and truly over 30,000 pieces per square metre. And this wasn't a one-off, it was continually, and it has been continuous for we've been sampling there since late 2018, and it's been fairly continuous since then. Unfortunately, a lot of this source reduction stuff has not been investigated any further, so we're hoping into the future that we might be able to look into this a little bit more as to the potential sources. But one of the questions that was raised was, okay, we've got all this debris in the West Lake system. Is it flowing through into the Port River, particularly into the dolphin sanctuary and to the surrounding wetlands? So then we started the next study, which was with great support of the Port Environment Centre and funding, particularly by Port Adelaide Enfield Council, who have been absolutely amazing. And they've been a great supporter of ours for the last couple of years doing this work. And I couldn't do it without the wonderful, wonderful help of my awesome volunteers. I think a couple of you are online today, and of course Emma and now Charlotte at the Port Environment Centre. I'm sorry that I've absolutely covered your place in microplastics now, and I don't know what I'd do without you. Put it that way. So it's the wonderful help of you guys that we couldn't do as a citizen science project. We couldn't do a project like this without you. You'll also see up in this top picture here, all those bits there that you can see that the obvious bits of the red and the blue are all plastic, but every single bit there is microplastic. The loads that we were finding up around these wetlands were unbelievable, and I never thought we'd find numbers like this. So what we started to do was start to look at, okay, where around the Port River were we finding huge loads of microplastic? And so we sampled up around the Port River where we could. There's not a lot of soft sediment shorelines there. They were relatively low levels. What we found though was when we started to look at, it was accumulating greatly in the wetlands, what I call Wicker Street wetlands, and then Barker in wetlands, Carp Pond in particular. This area here is actually a pylon from the Broadwalk in Barker wetlands. Now, someone strangely said to me, is that how plastic's made? No, that's not how plastic's made. That plastic came down with such force that it embedded itself in this pylon. So the plastics come through the system, through the stormwater network, and land in there. Now, we were getting values up around 750,000 pieces per square metre. And my wonderful volunteers counted just about every single piece of those. So thank you once again. Okay, so then we needed to start to get an understanding of, okay, we know there's this plastic, where's it coming from? So a young guy by the name of Clement, he helped us from the University of South Australia start to map some of those potential sources. Now, those sources can be everything from plastic manufacturer, it can be from potentially rubbish dump, it can be a playground, it can be tyre manufacturers, you name it, there's lots of potential sources. So to start to get an idea where you can then look at these potential sources and map the stormwater network to see where it's going to flow to, we can then start to understand where this is coming from and how to stop it. But this is not a way of doing it. Unfortunately, there is people out there, companies out there, that they think that this is the way to do it. So that's what we're trying to solve in this story. So when you start to look at the stormwater network that flows into the wetlands, you can see the nodes all flow into the wetlands. So we thought, okay, by trapping the nets off all of these wetlands, we can start to get an idea as to which catchment brings in what. And this has been very successful over in New South Wales. We've been very successful with this study over there. So what we did then was put some stormwater nets, pardon me, end of pipe nets down on some of those stormwater outlets that flow into the wetlands. And then we can track back up the catchment. We have to do it in open flow, back up the catchment. We can then put street level drain traps to be able to capture it before it actually flows down into our stormwater network. So we're stopping it at the source. It's not the ideal. We want to stop it before it even enters those waterways, but that's the next step in this whole picture. So we can install these nets, pretty simple plankton nets. Unfortunately, a lot of the characters out there, including no doubt young boys that want to use these nets to go and catch their own small fish in waterways, have taken quite a few of them, but nonetheless we've captured some. And so this gives you an idea of how we capture it. So when the flow comes through, we capture that first flow of water that comes through following a rain. And then we lay it out into trays, as lovely as that looks. Don't you all want to come and join us by now? Yes, no, probably not, but it is fun, I hope. And then you get people like the wonderful Joe Hendricks out there trying to sort the microplastic. And we put the street level traps in as well. So this stops the stuff when it flows in off the roadside, and we can capture it in these big traps. And then we can, and this is the stuff, as you can quite see, all these pieces in here are all plastic. So we're trying to capture this stuff before it lands into our waterways. And in amongst all that, what we're trying to do is work with a group called Operation Clean Sweep, which we do, which is about making zero pellet loss as part of the industry's goal. So within an industry, within plastic manufacturers, is trying to stop it right there at the organisational level before anything is released. That is the ultimate aim, and that's what we're striving for across all of South Australia. So what can you do to help? Just come and get involved. We do a lot of stakeholder engagement and education, which is what we're here for. And we work with local schools. We have educational material that's directly linked to the Australian curriculum. If you're a teacher out there, please get in touch. And we can run interactive workshops working with Port Environment Centre and other local stakeholders and run these programs all over the state. But we need your help. This is my awesome volunteer intern, Liv, and we're just waiting for you to come and give us a hand. Either get in touch, scan that code. We're always looking for help. So if you're interested, please get in touch. Just a final note, a few things, Plastic Free July, what you can do, please don't make this a normal habit. If that's in your street where you see bins like this, please go and have a chat to them if you can. Otherwise, send Charlotte. I'm sure she'll go and have a chat with them to try and it's about you yourself minimising your own plastic footprint and being aware of what you can do ultimately individually about minimizing your own plastic footprint. These things are easy to stop. It's just those extra things that we need to go that extra mile. But the one thing I'll leave you with before I lose my voice completely is all I like to say is do the best you can until you know better. And then do the best you can until you know better. Then when you know better, do better. And that's it from me. Thanks, Charlotte. I'm going to sign off. My voice is done.
Yep, totally fair, Michelle. Thank you so much. That was amazingly insightful to hear about all the work you do. I mean, I see it at the centre, but it's great to really have that context and to know what is being done in a broader context. So yeah, that's wonderful, and I'm very happy to support everything you do. Definitely, please give your voice a rest. We're so grateful. So we'll move on now to Nina. If Nina's ready to share her screen.
Yes, I think, oh yeah, there we go.
Fabulous.
How's that looking? Is that the right one?
That's great. Fabulous. Cool. Over to you.
Good, thank you. Thanks so much. I'll echo what Shah said. Michelle, that was amazing. What Osmap do is so amazing, and I think that leads so nicely into my talk as well. I did have a bit of brief stuff on the plastic stuff, but you nailed it. So I don't think I need to go into much detail about what microplastics are or anything.
Well, so that's why we complement, Nina, like it's all working together.
We actually do complement well. Your stuff is so broad scale and mine gets into a bit more into the nitty gritty. So that works nicely. Anyway, I would also just like to pay my respects to the land that we meet on today, of the Kaurna people, particularly to the sea country where the majority of our research is carried out. So I thought I would just start off with a little bit of an introduction. So who am I? My name's Nina, obviously. That is my little puppy Pam. Sadly, not so little anymore, but still is cute in my eyes anyway. And yeah, so I'm currently working as a postdoctoral researcher at the University of Adelaide. My research spans across various areas of the ocean, mostly in marine plastic pollution, which is obviously here what I'm here to talk to about today. But I'm also currently working on a really cool project involving a lot of school visits where we teach students and community about the importance of marine protected areas and sea country. So if that interests you, definitely feel free to reach out to me after the talk. So today I'm just going to be talking a little bit about some of the results that I found during my PhD, which I finished up in the middle of last year. And then also I'm going to be touching on some future research that is happening in the microplastic space, currently here in Adelaide, in our lab group. Yes, so as Michelle said, plastic. It's durable, flexible, long-lasting, and unfortunately has found itself embedded in almost every corner of our planet. As even as we try to be as good as we can, I can guarantee you, as you look around your room right now, you'll see various pieces of plastic. Even in front of me, I have drink bottle, pens, my computer has plastic in it, synthetic clothing. Unfortunately, it's quite hard to avoid. But yes, it's grown significantly since it first became available on the commercial market in the 1950s. And now we globally produce more than 380 million tonnes each year. And unfortunately, that's only going up. So we know there's a heap of plastic being produced, but where is it all going? Some, yes, is reused and recycled, others into landfill or unfortunately infiltrating our environment. Some of these include indirect and direct pathways into the ocean, and it's now estimated that somewhere between 4.8 and 12.7 million tonnes of plastic waste enter the marine environment each year. So plastic is now ubiquitous through the entire marine space, and it is found across coastlines, embedded in Arctic ice, deep in the sediment and floating on the sea surface. So this is the stuff that Michelle touched on much better than I can, but I'll just very briefly say pretty much that as these larger bits of plastic enter the environment, they're broken down into smaller pieces, and this can happen via UV sunshine, wave action, and also biodegradation as well. And yeah, these tiny bits of plastic, which are now famously coined microplastics, are less than 5 millimeters in size. and as time goes on are going to become one of the most pervasive contaminants in our environment. So plastic and microplastic have been documented in many marine species, from large animals such as whales, turtles, and dolphins, benthic organisms like crabs and prawns, in filter feeding oysters and mussels, in seabirds, as Michelle showed us that photo of, in krill, in sharks, and in fish. When it comes to fish, what negative effects could microplastics be causing? So suffocation and death, if they're consuming enough of it, yes. False satiation, which is where they have a decrease in appetite, leading to a lack of nutrients from other food sources because they're so full of the plastic. It is thought that this can cause a reduction in their health condition, but also on a broader population level could have hormone disruptions, behavior changes. Some of this stuff is caused by the chemicals associated with the plastic, as Michelle was saying, the chemical cocktail that these plastics can create. And this could also cause major shifts on an ecosystem level, which is what we're quite concerned about. And that could eventually cause problems for fish stocks in the future. So during my PhD, I really tried to quantify how much plastic these fish were eating, from an Australian perspective, I guess. But now as we go into the future, we're trying to figure out a little bit more about what the effects of these plastic might be having on the seafood and what this could cause to this, what negative effects this could cause to the seafood industry as time goes on. But I'll talk to you a bit more about that as we go forward through the presentation. So yeah, locally here in Australia, there's limited knowledge on the consumption of microplastic in fish. Well, there was, it's now growing because we're doing a lot more in this space. But when I first started researching this, there wasn't much information at all in Australia about microplastic in biota in general, to be honest. But seafood species, fish, crustaceans, bivalves, it was all pretty new. And now we're finally putting some numbers on it. So that means we can continue on and find solutions and take action. During my PhD, I sampled over 1,000 fish. So from 14 different species, from a variety of fish markets that I brought from seafood, from seafood shops across Australia and Fiji, just trying to figure out the amount and type of plastic that these fish in Oceania were consuming. Just briefly, I won't bore you with the methods, but we just took out their stomach contents. So we only looked at the stomach contents. We are doing some other work in our lab, which I'll touch on briefly, looking at the fillets of fish and seeing the chemicals that are tied to those. But for this work, it's only in the stomach. So the chance of it being a contaminant for humans is probably quite low. But yeah, took out the stomach contents, and then using a microscope, we identified the plastics and then used spectroscopy, which is a long chemical term that pretty much tells you what type of plastic it is. So the polymer type, which Michelle was talking about the polymers before, and it can tell you the type of plastic, which can lead us back to a bit about sources, which is really important. So just briefly, I'll just a little bit touch on what I found. So across Southern Australia, we sampled fish from all of the coastal capital cities. So this included Perth, Adelaide, Melbourne, Hobart, and Sydney. And we found that 36% of the fish had microplastic in their GI tracts, just an average of just under 1 piece per fish. And yeah, there were differences across the different species and between the cities. If you want to read a bit more into this, you can scan that QR code. Or send me an email afterwards. I can send you any of the papers that we have that have come out surrounding this work. And then I also had a different study which compared fish purchased through markets in Queensland and Fiji. So both still countries within the Oceania region, but very different lifestyles and different, I guess, like plastic legislations as well. So we were trying to focus and see if there any of these things were coming across the two different regions. So we found Australia had more microplastic. 62% of the fish had plastic compared to Fiji, where only 35% had plastic, and yeah, nearly double the amount of plastic per individual fish. But fear not, don't worry. Although these results can be a little bit disheartening, we actually then completed a global review where we looked at all the studies that have been done all over the world, looking at microplastic ingestion in fish, and we found that Australia actually has a lot less plastic in our seafood species than what is happening globally. It gives us a free pass to eat a bit more seafood here. And I always say to people, like, I would never stop eating seafood because of plastic, because as Michelle was saying, we're as likely to be breathing it in or getting it from vegetables. So I never say, like, you're going to be like, stop eating seafood because it could have plastic in it, because that's not good for our fishing communities either. But yeah, we do have less than what's been found globally. So shop locally and eat Australian seafood. Yeah, so overseas, I mean, there's such a variation in the abundances of plastic that are found in some of these studies. Like, some found, 180 pieces in one individual fish, and some found such low numbers like we did. But on average, there's about 3.5 pieces per fish. So that's, kind of 3 times more what we found in our Australian samples. So what could be causing fish from Oceania to have less plastic than globally? We found that the diet of the fish, so what the fish were eating, did impact the amount of microplastic that was being consumed. The trophic level also impacted. So trophic level is kind of where they sit in the food chain. It's probably a good way of describing it. So actual, like, fish that sit a bit higher up the food chain found to have a little bit more microplastic than fish that were lower in the food chain. And that kind of makes sense, I guess, because they're probably eating fish that already have plastic in them. But yeah, then in regards to the differences between Australia and Fiji, it was hard to know what was going on there, if it was to do with the lifestyles. As Michelle was saying, figuring out the exact source and origin of the plastic is difficult. It takes a lot of extra steps to be able to figure out where this stuff is coming from. And we didn't have that while we were sampling seafood. So providing these definite answers is hard, but I guess we can kind of infer different sources and why different places might have more plastic. So in regards to the type of plastic we found, so Michelle touched on before kind of the 3 main, well, I guess the broad categories of plastic. When we look at our samples under the microscope, we break them into kind of 3 categories. One is fibers, one is film. So film is like, I always say picture glad wrap, a little tiny piece of glad wrap. That's what a piece of film would look like under the microscope. And one is fragments. So that might be like, if this pen was to break into a tiny piece of plastic, that would be a fragment. But fibers, we found the majority of the plastic we found in all of our fish samples was fibers. So more than 80% were this type of plastic. And that led us to think, where is this coming from? So the first and the most probably problematic source is from synthetic clothing. There are some studies that estimate that over 1 million pieces of microplastic enter waste systems for every load of washing. So those numbers are actually terrifying, because these plastics are so small. I mean, some of these are definitely more nano size, like they would be unidentifiable to the naked eye, but they're tiny, and there are actions we can take. There's this thing called some of you may or may not have heard of this, but it's called a coral ball, like CORAL ball, and you put it in your washing machine, and then it like attaches onto all the little fibers, and then when you take it out, you can peel off the fibers that are attached, and rather than going through the system into the ocean, you can take that little ball of microplastic and put it in the bin. Which obviously then goes to landfill, which is another issue, but at least it's not going straight out into the ocean. I'm not entirely sure how effective they are. I've heard mixed reviews. So, I mean, it's better than doing nothing. You may as well try. So yeah, synthetic clothing is one of the major sources. And then the other source, which is where I'm going to talk on a little bit next, is coming from fishing gear. So these broken pieces of rope and net, you can imagine if a synthetic piece of rope that would be used in the fishing practices, like you can picture the little fibers of it, that might have been some of the plastic we found. And we did find in our samples like very obvious bits of fishing net and things like that. So I'm going to touch on that a little bit now. So how the fishing industry is contributing to plastic pollution is an ongoing kind of question. Michelle mentioned that 80% of plastic is coming from land-based sources. So that obviously leaves 20% coming from ocean-based sources. And this can be things like shipping containers, like nurdles going over the edge and that kind of thing. But there's a little bit of question of like the extent of the fishing industry's contribution. And I hate playing blame games because I don't think they're obviously using the ocean more than other people. So naturally they're going to be putting more plastic potentially out there. But there are some studies that suggest, 10% of microplastic in the ocean can be linked to fishing sources. There's one study that sampled microplastic in the Great Pacific Garbage Patch, which is that giant floating patch of plastic that people may have seen photos of on the internet. And within that garbage patch, they suggest about 50% of that plastic is from fishing industry connections. So these numbers are a bit hard to quantify, which is something that I'm trying to do as part of this future research we're doing at the moment, which I'll touch on in a bit. But yeah, still big question marks over the extent that the fishing industry is having towards the microplastic problem. But yeah, as I've been saying, the fishing industry is contributing to the problem. There's no doubt about that. Willingly or not, most people I think definitely don't mean to do it, but occasionally nets might go overboard or whatever, and there's nothing. Well, there is things you can do about that, but limitations, I guess, people can plan to not have their gear break down so easily that it would break, but that's right. We'll talk about that in a second. But yeah, so unfortunately they are contributing, but also plastic itself is also negatively affecting the fishing industry. So obviously, as I've already identified here, some of this plastic, these fish species are eating plastic, and this could be causing ecosystem level health problems, as well as, just to be honest, people like who are in this group today talking about this may be less inclined to eat seafood if they hear there's plastic in it. So it can have negative livelihood effects for fishers. So yeah, it's even though it is a little bit unknown how plastic may be affecting us as humans, I think like we're all cautious on what we do and what we put in our bodies so much now. And there's a chance that consumers could choose other protein sources to form their diets if if more and more plastic is showing up in seafood. So this is why we decided to work alongside some of the key seafood industry stakeholders to discover some potential supported management strategies which can be used now and in the future to hopefully lower plastic use and improve disposal within the seafood and fishing industry. So I interviewed fishmongers, recreational and commercial fishers from the marine scalefish fishery here in South Australia to highlight their levels of knowledge and concern, and to sort of brainstorm ideas on how we could lower plastic use and improve correct disposal within their industry. And we wanted to make sure these were things that fishers and fishmongers believed will be accepted within the fishing community, because there's no point just creating these rules and regulations that nobody is going to follow. So after talking to the fishing community, we came up with 3 kind of main overarching strategies that we worked alongside with them for them to believe would be accepted within their industry. The first thing is, and this one is key, and Michelle has talked on this, and this is something that everyone here can do, is plastic pollution education. So a lot of the people we talked to didn't know much about microplastic at all, and particularly didn't know much about its presence in local South Australian waters. So Michelle was saying, we all think and picture that South Australia is so pristine. And yes, it is. Like the fish that we sampled is a lot cleaner to, say, international beaches. But there's no point patting yourself on the back and saying, oh, job well done, because we still have a huge problem here. And we need to make sure that people like the fishing community, are educated about that and realize that it's a problem. So that was the first management strategy we came up with, which was plastic pollution education. The second one was to do with improved disposal facilities. So a constant thing that came up with pretty much everyone I talked to was that there weren't the facilities at jetties and boat ramps for, or even local waste disposal sites for their fishing equipment that is plastic made to be disposed of correctly. So I'm obviously this is talking about bins and, you know, rubbish places at jetties and boat ramps, but it's also talking about within the actual facility, like things like large fishing nets. People didn't really know where to take them. So working, I guess, alongside councils with this management strategy and also with the plastic pollution education, this stuff can kind of fit hand in hand. And the final thing that we came up with, which I found so exciting, but was that there was like generally a really, really good acceptance and excitement to do with the use of a plastic-free fishing equipment. So everyone said, I think there was one person who said they wouldn't willingly use a natural alternative as long as they were as cost effective and as efficient as the plastic gear they currently use. So if we have any engineers out there, there's I think a potential huge area of growth, because right now the market in this is so limited, but it definitely poses well for the future. So if someone can figure out some very effective plastic-free fishing gear, I think you have a lot of people that would willingly at least trial it, and hopefully down the track this will help out. So that brings me to the end of the research that I have currently completed. I thought now I'd just touch quite briefly on a little bit of the research we're doing in the plastic space within the Galanda's Aquatic Ecology Lab. So that's my research group at Adelaide Uni. We currently have 4 postgraduate students who are working on plastics, as well as 2 postdocs and a few undergrads. We're all part of Bronwyn Galanda's lab group, who's a keen and big name marine biologist here in Adelaide. And yeah, we recently made a quick video, I hope this works, that summarizes all of our research and will describe it way better than I can. So let's see if this works. It's short, hang on. Let's hope this works.
So many things, but the average person throws away 52 kilograms of plastic waste every year. And sadly, too much of this ends up in the ocean. Unlike your banana peel, plastic never goes away. In fact, every plastic object that has ended up in the ocean still exists. Instead, it breaks down into much smaller pieces, microplastics, less than 5 millimeters in size. But these tiny bits are a major problem for marine life and those who rely on it for food. That's why at the Galanda's lab at the University of Adelaide, we're working hard to better understand this growing problem from every angle. We're investigating how plastic becomes microplastic once it's in the ocean, how thousands of marine microbes colonize each piece, causing further breakdown and even using the plastic as a vehicle to spread disease. Plastics contain harmful chemicals and inconveniently act like magnets for substances suspended in the water. These substances mimic human hormones, which is a big problem as they've been shown to decrease fertility and cause cancer. As microplastic finds its way in between the roots of mangrove forests and seagrass meadows, it harms young critters feeding in the cosy habitat, as well as those who feed on them. And with many of the most popular seafood organisms likely eating microplastic. If we don't do something now to change things, it could be more than just seafood on our dinner plates. Visible plastic in the ocean is bad enough, but for the health of the marine environment, its inhabitants, and ourselves, we need to broaden our attention to the large-scale hidden consequences of microplastics. So visit our website to find out how the Galanda's lab is investigating where microplastics are coming from and the effects they are causing. Only by understanding this problem will we be able to find a solution. galandaslab.org.
So yeah, as you could see in that video, our research spans way beyond what I've just been talking about there. We're looking also in mangroves and seagrass, in a variety of different marine animals, trying to identify what chemicals bind to plastic. And that's Sophie, who's also, I think, on this call now, is what she's working on, as well as the plastosphere and the different microbes that are transported on plastic. We also have some projects we've recently started. So this is just what I was talking about before. We just received some funding through the Fisheries Research Development Corporation to look at how plastic is affecting seafood species and the seafood industry, to hopefully be able to also quantify the kind of contribution that fishing and aquaculture practices are having to marine plastic pollution, and also to see if there's any kind of opportunities of plastic in the seafood sector. And we also have a few NEST projects going, the National Environmental Science Program. One of these is a bit of a scoping project that I know Michelle's involved with. We're trying to consolidate some of the research that has been already been completed across the southeast of Australia. And also we're now looking at creating some standard operating procedures for microplastic research. So yes, in conclusion, unfortunately, microplastics are spread globally, but yeah, even I think there's some stuff that little things that everybody can do. Obviously, as Michelle was touching on, the small actions like using your keep cup, buying natural clothes. That's always my #1 recommendation, is don't buy synthetic clothing. It's hard to be perfect, but do the things you can do. Or there are bigger actions like running education sessions or volunteering for groups like Osmap or Adopt a Spot, writing letters to government, all these kind of things that people can be doing. There's lots of amazing up and coming solutions that have been developed at the moment. Last week I heard about this little robot fish that apparently swims around the ocean and gets nanoplastics to stick to it. Don't know how well that will go, but we'll see. There's also a cool startup in WA called Ulu, which uses seaweed as a plastic alternative. That stuff's really cool. There's even a group over in the UK that's using fish scales as a way to create alternatives to plastic. So there's lots of stuff happening in this space. I think we just need to ride the wave and all try to lower our use as much as possible before we have these appropriate solutions coming in. Thank you to everyone for listening. If anyone wants to reach out, here are some of my contact details. But otherwise, thank you so much. Sorry if I went a bit overtime, Shah. I feel like I definitely did.
No stress, Nina. Thank you so much. That was great. Definitely some kind of harrowing statistics there, but great to know about what you're doing to kind of empower industry, and also what we can do as individuals. I've definitely taken some good tips for myself. So I'm just conscious of time. I'll pass over to Chris now from Adopt a Spot, and he can quickly share, and then I'll leave all the contact details in the comment section at the end if you want to reach out to anyone, and we might have chance for a couple questions, but I'll pass over to Chris now.
Okay, can you hear me?
Yep, great.
Yep, okay. Thanks for those two presentations. It's because of those presentations that have converted me, and we're onto it. Our group, for those of you that don't know, we're a marine debris removal group called Adopt a Spot, and we are reaching out and encouraging local members of the community to join with us and help clean up a spot that they're passionate about. It started off just being surf spots, and it's grown into this massive thing that's probably needs a bit of sorting out. But it's great that we're getting the people involved, because, as I said, we started off as surf spots, but people from beaches all up the coast have wanted to be involved and asked if they could join, which has been great. We were concentrating mostly on beaches. We were looking at the strand line and picking up just small bits of plastic and measuring them, like handfuls of that. I can see that. Got stacks of it here. Unfortunately, I haven't got any slides. I wish I had now. But we soon learned that a lot of the plastics and that we were removing was coming from inland and from the creeks, rivers and waterways. So we started recruiting people that wanted to look after stretches of creek and river rivers, stormwater outlets, which are my favourite thing, up and down the coast. And that's been really successful, particularly in the southern suburbs. We've got so many adopters working on all the inland creeks. But unfortunately, what we're finding is that, and you can see the research on our pages as well, that each adopter will go back a week later and take almost an identical photograph of what they took the week before. And I've shown this in many presentations. So we realise now that it's going to be an ongoing thing. We've started to trace back the debris that we're finding and trying to get back to the source. And the reason that we can do that is because each adopter identifies their own spot, and when they report on target items and a brief description of what they got, but also a photograph that we can look at. Each one of those photographs gets put into their own separate album. So anyone that's wanting to look at a spot and see what's happening and where it's all coming from can go onto our website, which is just opened up, and there's a map on there of all the spots. And so if you're interested in a particular area, or you wanted to adopt a spot or see how things are traveling in certain areas, if you go onto our website and click on the location, it'll send a link to that spot's photo album. And so you can go through and see everything they've done since they've been adopted spot. Some people have been with us 4 or 5 years, and the research and their little bits of research go back all that distance. It's improved as we've gone along. It started off very crude, but now people are really starting to get into it, and the people that are coming to us now are really looking into this, itemizing all the items and doing a lot better job with that. So that's it. I've got some stats. We do quarterly stats, but unfortunately tomorrow is the last day of the second quarter, so we haven't prepared them, but I can just go by the first quarter stats for which is from January to March. So in total, we've done 726 cleans. We've removed 1,042 kilograms of rubbish. And you saw from before what I mean. I'm not talking about couches and car bonnets and tyres. I'm talking about tiny little bits of plastic off the beaches and out of the creeks. There's a lot of soft plastics. We've collected 8,833. I mentioned butts, and I'll mention Coke bottle, soft drink bottle lids, because there are 2 target items, because they are the 2 most common identifiable single-use plastic items that we are collecting. So obviously our biggest one is plastic fragments, but we don't always know the origin of them. So out of the identifiable ones, or as I say, the ones we can do something about, cigarette butts and bottle lids are our main thing. Oh, sorry, I'll just go jump lines here. Sorry, I should go back to that and say, sorry, the butts collected were 26,871. That was 8,000 butts just for March, I should say. And bottle lids, so far, 2,176. So we found out that a lot of people are saying that PET bottle lids and things like that are the most common plastic, but cigarette butts will beat them 10 to 1 in what we're picking up and what we're finding. And once they hit the ocean, they're hard to find because they sort of blend in with the environment as well. Volunteer hours, we spent 1,219 volunteer hours in the first quarter, and with a value of $54,855 to the community. And we are now measuring the students reached. We reached 183 students. Some of that was via the Marine Discovery Centre, but we have schools that adopt spots, and we have a schools program where we go out and do presentations and try to get them to join us. We have churches, community groups, sporting clubs, and anyone that we can reach, we are invited. We're so diverse in the adopters that we can have, because each adopter nominates their own spot, so they're just going to get something that's within their own capabilities. We even have a disabled group, I suppose you'd say, that look after 2 parks in Christie's Beach, and they go out once a month as a group, and it becomes their get-together because they've got the facilities there, the toilets there, the ramps and everything. So that's their contribution to it. Also on our stats there, so up to the end of March, we've been cleaning consecutively for 1,064 days. So what's happened is that someone from Adopt a Spot, or people from Adopt a Spot, have gone out every day since March the 2nd, 2018. That's through Christmas days, all through COVID. Because it's such an individual thing and people can do it as they want to, they've got this record going where they really want to keep it going. So we reached 100,000. We reached 1,000 consecutive days on Australia Day, actually, this year. And we're still going unbroken. So you can add another 90 something days to that. So we're still going unbroken record. We had 201 adopted spots out throughout the state. That's going to reduce. We've done a bit of a clean out. We're starting to get rid of people, or people that are contacting them who we haven't heard from for a while, and we put out an invitation, look, do you still want to be involved? And they've come back, and some people want to move on, and you get that a lot with people. They're great for a while, and then they move on to something else more important, or not more important, but something else that they want to do. They just get sick of it, or they move away from an area. We've got about 390 volunteers when you add them all up, because sometimes it's a single person, husband and wife, family, then you get your sporting groups and churches. Lions Club have got spots down our way. What else we got on here? Oh, we got our website online just in the last 2 weeks, and I invite everybody to go and have a look at that. And that'll do for stats, I reckon. That's enough of that sort of thing. So we're pretty active. We are just a community. Our status is a not-for-profit community group. So we're at the lowest rung of the ladder. We do get funding mostly for projects. So we've had funding from SA Water to create our video. Now, I did release a video earlier in the year, but one that the person that funded it saw it, they wanted their name taken off it because it wasn't too complimentary to a certain person. So we've had to just re-edit it, and that's going to be released back onto our website. And this week we've got a meeting on Thursday when we do the final stats for this quarter. And so the main reason why I wanted to be involved in this, because I wanted to draw everyone's attention to Tam O'Shanter Creek, which is in the Port River. It's the very start of the Port River. It's where all the stormwater goes from the suburbs and enters into the Port River. It's right at the beginning of the dolphin sanctuary. We've done a few group cleans there, and we always get a trailer load of rubbish out of that part of the creek. Now there's a lot of really good infrastructure further up, but this is all the other stuff that has escaped the infrastructure and is now in the river and is never going to be cleaned up unless people go out there and pick it up. There's nothing further downstream that's going to get it out of the system. So we're hoping to get some adopters or a community group or someone that wants to go down there regularly or monthly and just do the outlet there at Tam O'Shanter Creek. We've done it. We've had people with interest that they've done it, and it is a little bit of a big job. And there are toilets and all sorts of facilities there, and barbecue area, so it's perfect for a community group. But that would make a big difference to the dolphin sanctuary, because we've actually got no one at the moment working inside the Port River. We had people there. We had people at Snowden's Beach, which is another great spot for an adopter, but they've sort of moved on. Down the coastline, we're looking pretty good, and I can see that some of the adopters from your beaches here are watching tonight. So thank you to all you guys for that. But I'd really love to get a bit more activity in the northern beaches. I'm from down south. I only live 40 metres from the water's edge, so I see everything that's going on, and I have ventured up there to do group cleans with Refuse, Reduce, Recycle group, Laura Carrington from up your way. I've done a few group cleans with her, and we've gone up there. So that's what I'm hoping to get out of this meeting anyway, plus just to let everyone know about Adopt a Spot. So that was pretty rushed. Is that good for 5 minutes?
Yeah, that's great, Chris. You covered a lot of ground there.
That's a real jam out here.
Yeah. And oh gosh, what a mammoth effort. It's amazing the stuff that you do, and clearly getting some really good results and getting some great heaps of plastic out of the waterways.
Yeah.
I'm just very conscious of time, so I might leave questions. If you have any burning questions, I've put everyone's contact details, their emails in the chat, so feel free to email them your questions, get involved with AUSMAP, get involved with Adopt a Spot. And I'll just finish by saying at the Port Environment Centre, we are hosting a Sunday session on the 10th of July, all about going plastic free, transitioning to low plastic. So come by and chat with Taryn from Plastic Free SA if you would like. But yeah, some great connections happening in the chats. Really appreciate everyone coming along. And this video is being recorded, so it will hopefully be made available for anyone that missed out. But a huge thank you to all the speakers. That was, yeah, fantastic, so insightful. And we're really grateful for all the wonderful work that you do. Cool. Thanks, everyone.
Thank you.
No worries. Bye.
Everyone.
Yeah.
Bye.
See ya.
Thank you. See ya.
Thanks.